Okay, so now we're going to work on this final. I didn't actually use any of those raster data sets. Maybe we'll use them next week. Those other ones, the climate data. But now we're going to work on this last assignment. Okay? So just be consistent because we gave you another week to do today. We'll have 2 weeks to do this. All right? So the data that you're going to download is in the TyDixton folder. Okay? And it is actually vector data. So we're talking about raster data, but we're going to start off with vector data. So what your script's going to do is there's a number of shapefiles in there, but I only want you to use the shapefiles to start with risk. And there's actually a few different ways to do this, but we're going to. I'm gonna help you code that part because it's kind of interesting, nice way to get a bunch of data sets. All right, the next thing that you're going to do is use the Euclidean distance tool. This is a tool in Spatial Analyst that basically creates, it's a global tool that creates, in every cell is going to be the distance, the straight line distance from that cell back to the closest point in the original data set, in the vector data set. Okay? So this one is creating a new raster data set. So it's really important that you set the cell size and the extent here, right here, before you start doing this. Because if you don't, it's only going to be the extent of that cell, of that data set. Okay? Now the next step is you're going to adjust these outputs so that instead of being from, 0 will be the shortest distance all the way out to the edge of the data set. Now you're going to change it so that they'll be from 0 out to 1,000, and then you'll have no data after that. Okay? So 0 out to 1,000 and no data out there. And then finally, you want to reverse the values so that you have zeros everywhere you have 1,000 and you have 1,000 everywhere you have zeros. So to do that, it's just a subtraction problem. So you take 1,000 and you subtract the original data set, and that if the original data set was 0, you'll get 1,000. If the original data set is 1,000, you get 0, and you get everything else in between. Okay? And then the final thing where you're going to need the eval statement is when you add them all up. Add up all the data sets and save the output. Now you could do that a little bit differently. Since we're dynamically creating all these data sets, it's the proper way to do it. Okay, so I'm going to kind of stub out the first part of the code where we're just looping through each of the data sets that starts with risk. Now we're still going to need to do all of this stuff here. So I'm just going to start with this, but I'll save this as Raber _10_1 2018. So we got this data set, okay? And then we need to find, did we actually download that data set yet? I don't think I downloaded that data set. Yeah, the TyDixton one. You downloaded it? But I don't know if I think that I downloaded just the first 3. Yeah, see, those are the only ones I have there. So let me download it real quick. Open. This one is just a folder, and I'll put this in C, temp, SPA lab, week 10, TyDixton. And these are shape files. So I'm going to set that as the workspace. env.workspace equals to that. This is, I don't know if I've used this data before in this class, but this is a watershed in Jamaica. Refresh. I've used it in other, oh yeah, it is. I use it a lot in classes. Okay, so yeah, watersheds. This data set here is going. This is going to be the extent, so we can use this as the extent. But we have to specify a cell size because we're going to be creating them all from scratch. It doesn't really matter to me what cell size you use. But let's establish one now so that it's a reasonable cell size, right? We don't want it to be too big and we don't want it to be too small, because if it's too big, well, we're going to get too few cells. If it's too small, it's going to take forever to process. So I'm just going to, and if you don't use the exact same one as me, that's fine. I'm just going to measure a distance here. I can't even see these things. Let's do it in ArcGIS. I mean, it's still really small. SPA Lab. Week 10, Ty Dixon, watershed. In the past, I think I've done 50 or 100. Let's see how big this distance is right here. It's about 107. Yeah, so let's do let's just do 100 because that'll make it run faster. Okay, so we'll use 100 as the cell size, and this is going to be the extent. So I am going to set that as the workspace, but then, oops, I forgot that I could also use this information. So I resurrected it. I already closed our catalog. So I want to get the, I'm going to use this as the extent. Actually, like this. That'll let me get rid of both of these. And the cell size, I just have to set it at 100, 100. Okay. So those will be the extent and the cell size. All right, so now I'm all set. Now I can create those Euclidean distance layers. But first I need to loop through them all. And to do that, I don't know if I did this earlier in the semester or not, but there is an ArcPy list feature classes. And what it does is it lists all the feature classes in a workspace. Yeah. Good. So here's the help. So I'm going to say feature classes, arcpy.list feature classes, if you'll notice in the help, it does allow us to insert what they call a wildcard. So we only want those that start with risk. So you can type in risk star, and now it's only going to list those feature classes that have a risk at the beginning. So notice I just wrote print FC. And if I run this, it's going to print out only those feature classes that start with risk, or that have risk at the beginning of their names. So there's an equivalent for listing rasters. There's an equivalent just called list data sets. It doesn't matter if it's raster or vector. So that's a tool there. So now I'm only getting the risk data sets out. The risk data sets are the only ones that I'm getting out, that I'm only going to operate on. So now, what I need to do is to calculate the Euclidean distance for each of those data sets. So the best way to do that, I think, is to find the help. So you can do that in ArcGIS, or you can do it online. ArcGIS, Euclidean distance, ArcMap. I always put ArcMap in there. I explained that before. It's because okay, so there should be some help down here, yep, that shows how to do it. All right, so this is how to do it. We don't really care about the direction raster. The direction raster will tell us what the direction is back to the feature. That's not important. So let's just delete that one. The cell size, since we set it, it'll use the environment one, so we can delete that. Okay? At least it should. If it doesn't, then that'd be weird. Okay, the in data source is going to be the feature class each time through the loop. And the maximum distance, this actually will save us a step if we put the max distance in there. If we put the max distance of 1,000, then we won't have to cut it off later. So that'll be good. All right. Now, where's it going to save that out Euclidean distance? Where's it going to put that? It's the same trick question I asked before. What's that? It's not going to save it anywhere until we tell it to save it somewhere. Okay? So that's the answer. Right now it's just in memory. So if we want to see it, we have to save it out. So we have to do out Euclidean distance dot save and then save it somewhere. What I'm going to do is say fc dot replace What does that do right there? What's that line going to do? What's it going to save it as? What data type is FC right now? In fact, I just noticed an error in my code for the next line. It's a feature class, but really what is it? It is the path to a shapefile. It's the name of a shapefile. In fact, it's just a string. It's just a string. FC is just a string. So when we use it here, fc.shape, when we use it right here, all we're doing is replacing .shp with .tif. So we're just changing, we're giving it a new string with the .tif extension on it. Okay, but we also need to do this. Of course, that was the way it was in their help, right? They didn't actually write raster. Anyway, maybe it does accept a string as well. Anyway, okay, so cell size, Euclidean distance. It's getting too hot over there, huh?
Yeah, and I'm trying to jump there like quickly, and it's just not quick because somebody disconnected.
I wish I had a blanket or something.
I'm trying to cover with it. I wonder if there's one. I'm just gonna. I can never. I'm gonna break for this. I mean, break. You're ready for it. That one is stuck on like that part. You can also do that one because I've tried it several times and it's just stuck on that
I'm surprised why I know the same way from the
part.
Oh, you got it down.
You got it down. And I go like it's different because
It's
I'm
fine
trying
up here.
to get away from the sun.
Yeah. We don't need it up here.
What's
Oh,
that?
you need it.
Yeah, she was wanting this
No,
one
it's
down.
just damaging all this stuff and I've been trying.
Oh,
to
okay.
No, but if you can't,
It doesn't affect it for this class, though. I was going to get this, leave it up right there.
Oh,
It's kind of, they're so big. They're so wide that.
Oh, and it's funny because at the beginning of the semester, it doesn't bug as much as it does, now that the times change.
There we go.
It's never good to have those long blankets. Like next time you have to have like.
I have these actually upstairs in my bedroom. Well, they're like half the size.
Yeah.
Takes forever. Yeah. We'll have to order those next time. We can just say, okay, Google, close the blinds.
The fabric ones are great and they never do.
Yeah. All right. So I don't know why. I don't know.
The inputs for Euclidean distance can the input can either be a raster or a picture class. You don't need to put a raster.
Oh, thank you, Maggie. So we don't need to put that because it works as a raster or a vector. Okay. All right. So now it's going to save it out. Let's just run it at this point. Got some errors? See. Let's see what mine look like. Refresh. Those look good. They look right. Now, of course, they're going to cut off at the edge of the watershed. That's okay because that's outside the study area. If we wanted to make a bigger area, we could, but we're just going to leave it like that. Okay. You sitting over there?
Yeah, maybe.
Leave it up there for a second. Go back to the code. Looks like it's the object. So does this exist? Does this path actually exist?
You know what? It's in this.
Yeah. You have to just put the proper path in. You just cut and paste it right from our catalog.
Not really.
Yeah.
I have an error that says
that feature, footprint statement, print feature classes. No, up above it. So, up above where it failed. Next line up. Right below the feature classes. Just print that. It's empty. So go back here. So that workspace, make sure that path is right. Okay, so we've got it. Okay, so what I'm going to do now is demonstrate the eval statement, and then we're gonna leave it at that. There's a couple things that you all need to do to change it to make it work. The whole thing to work. All right. So let's look at back here at the description. Too many windows open. Okay, 10. All right. So we're gonna take the raw values and add them all together. That's what we're basically skipping. We're basically gonna skip 4 and 5 and go straight to 6. So really, sorry, we've already done 4 though, because these values that are out here, I thought of doing 4 separately, and that's the way I had it written up in my example that I did beforehand. But out here, if I select I, there are already no data past 1,000. See how it's already no data past 1,000? Okay. So really, all you need to do later is go back and do 5. Okay, 5. We're gonna skip 5 and we're gonna go straight to straight to 6. And the steps. So I'm going to demonstrate what if we wanted to add all of these out Euclidean distances up? We wanted to add each one of these data sets up. Well, there's a few ways we could do it. One way, which is less efficient but would still work, is to keep track of this out Euclidean distance, the previous one, like inside the loop, and always get the previous one and then print it. I'll actually do that. Okay. So out Euclidean distance, and then we could say out Euc dist pre is equal to out Euclidean distance. And right here we could say if is not equal to none. This is a demonstration of one way to do it, but this will be a little bit less efficient, but it'll still work. So I'm going to make sure that it's equal to none here. Equal to 9. So in other words, what I'm saying is out Euclidean distance pre is equal to nothing. And so if it's not equal to nothing, in other words, if it's gone through the step once, then what we're going to do is say out dist tot is going to be equal to out dist pre plus out dist Euclidean distance. Actually, this actually need, well, yeah. Yeah, okay. One more line here. second. I'm thinking logically. So, out Euclidean distance, okay, we'll just do this. Else, that'll work. Out Euclidean distance tot is going to be equal to out Euclidean distance. So in other words, if out Euclidean distance free is not equal to none, then what we're going to do is say out Euclidean distance total is going to be the previous time or plus previous plus out Euclidean distance. Yeah. Yep. And then if it's not, we're just going to, in other words, if it does equal 9, the output Euclidean distance pre has got to equal something, yeah. That's when it's just going to be the out Euclidean distance. And then otherwise, the previous one is going to be equal to the tot. So the tot will always be a running total. Messed up. Okay, let me see if my logic flows now. Okay. So the problem is with rasters, you can't have a value over here that's also over here. It's not like with numbers. So you can never have a value on the right side of the equation that's also on the left side of the equation. It'll freak out. So what you have to do is the first time through the loop, we're going to get here and it's going to equal none, so it's going to do this. So all it's going to do is assign the current Euclidean distance to the out Euclidean distance previous. Then it's going to come down here and okay, well, my logic is not quite there yet. There we go. So the out Euclidean distance total is going to equal. This is kind of like this step doesn't even really need to be. No, that step needs to be. So the first time through, the total is just going to be the current distance. Then it's going to assign that to out Euclidean distance free each time through. So we're always going to get the previous step plus the Euclidean distance to equal the total. And then it's going to relabel that free, and so that it'll keep incrementing through the loop. I think this will work. I wasn't. This is my alternative way of doing it. That's less efficient because it requires 10 sums, or not 10, 6 sums. So let's see if this works. And we're going to save the total outside of the loop. So we're only going to save the ending total out at the very end. And I'm just going to call this, I'll just call this total test dot tiff, because I'm trying to go for alliteration. Everybody remember what alliteration is? Yeah. That was an English test in the middle of a geography class. Yesterday, my son goes, "Oh, that's kind of like an onomatopoeia." I was like, I had to think about it for a second. What line is that? Out Euclidean distance pre. Well, it's the workspace, so it'll go into that directory. So it still doesn't seem like it's working, but it's failing on this if statement. So I think if I could come up with a better if statement, right? I think that's where it's failing, because it says if out Euclidean distance does not equal none. Well, Maybe it just doesn't like none. Okay. Let's see if this even works though. No. The truth of a raster is ambiguous. Oh, the use of a raster. Okay. It does sound like a portrait. Okay, so now it's going to do this. I don't think that should be a problem. But out Euclidean distance does, yeah, no, it does equal something. Okay, that equals that. All right. That logic actually seems a little more straightforward than the way I was trying to do it. Let's see. It's still here. It's created here each time through the loop. It's just that I no longer create it before the equation. So this is all the code here. I'll expand that out a little bit. I think that's working. Let's look at the total test real quick, and I'll go back to that. Where did I put it? Oh, tight Dixon part data. Total test, preview. There's no data anywhere. Oh, I know why. Okay. Sorry. You're going to have to do that step, number 4. You can't not do it. The reason is because no data plus no data is equal to nothing. So we're going to have to take this 1,000 out. I thought I was being clever, but there was a reason why I wrote it that way to begin with. So I've got to click off of this thing. Hopefully it'll not freak out. See if it might still freak out at the end. So anywhere there's a no data, the output equals no data. And so no data must have existed everywhere. And so let's look at these data. So this is still no data out here. Interesting. Hold on. I'm going to delete everything in here that is a TIFF, because those don't look right. TIFF. So anyway, yeah. So I thought this would be an alternative way to do it, but I don't know for sure why it's not working. So let me save this as experiment, and maybe I'll come back to that and go back to the way that I know that it works and that it's a little more efficient anyway. Okay, so we go back to this guy, close the experiment up. Okay, so I wish I would have saved the last one. But basically, this is the Euclidean distance that it's creating. And you don't need this. And we need to change this to back to the way it was before. FC dot replace dot or quote dot shp comma TIFF TIF. The reason that I think that it's safer to put dot there, like we don't technically need the dot, is that if you had SHP anywhere in your file name, it would replace TIFF there. But this will make sure that it only replaces it at that location. All right, so now that's back to the way it was. Okay, so we've got a bunch of these names. In fact, it might be easier to do this. Oh, sorry, I'm going to take this whole thing because we're going to need this name. So we're going to say that we want this to be the output name. Okay. And we're just going to put output name right there. Then what we're going to do is to have a output list dot append, and we're going to put output name in there. So we're going to have a big list of all of these output names. So we'll have one called, risk farms, or no, risk small scale agriculture.tiff, risk ag sugarcane.tiff. We'll have all those, and we're going to put them in a list. And what we need to do is to build an expression that looks like this. Name 1 plus raster name 2 plus raster 3 ... We need to build a big expression like that. Okay? All right. So we can do that. I'm going to make that a comment. We can do that with the big old output output list at the end. So we could do something like this. Output list. How do we take a list and squish it together? Take all the values and put it together. Remember that one? It's kind of the opposite of split a list. That's taking a string and splitting it where all the commas are. What if we wanted to join it back together and put commas or pipes in between? Do you remember that function? Join is it. Okay. Let's look at the help for that. Python join a list. Oh, it's actually string.join list instead of list.join in Python. All right, let's forget that. Okay. So it's actually like this. So what we want to do, this is going to look a little weird. So this is actually going to be the stuff in between the names. So what we want is actually this information right here, like that. That's the information that we want. That's the stuff that's going to be in between each item in the list. And then we're going to join this output list like that. And then this is going to be the statement that we want to. And let's just, for now, let's just print this statement and make sure it looks right. Okay, because it actually isn't going to look right, but we're going to see what it looks like. Yep. Thank you. And then I also want to change, interestingly, I'm also going to add little single quotes in the inside there. Output list is not defined. Oh yeah. So before the thing, I need to make an empty list. So like that. Okay. Now I think I've gotten most of the bugs out. It's still not going to look exactly right, but when it runs, you'll see that it'll look close. So I'm just going to leave the code up while it runs, just to make sure that it works. Yep. Okay. So this is the result here. See how it says risk, ag, small scale agriculture, quote, and then it has the other one, and it's adding them all up. So it's kind of like I'm dynamically creating a big plus statement, right? Okay. Now there's two problems. One is that I need a quote and a parenthesis at the end, and I also at the beginning need a raster and an opening parenthesis and a quote. So something like this will finish this off. So statement is going to actually be equal to, this is going to look a little weird, raster plus that, wait a second, oh, like that, plus, all right. So what's happening is that this is joining the list, and then this is taking care of the very beginning and the stuff at the very end. So it looks weird, but now when I run this, it'll be a full statement. So it's gonna run. I'll just go back to that for a second because it's going to take a couple seconds here to run. So that ran. So now it says raster parenthesis quote the name all the way down. It's got all of them in there. So it's this line looks kind of ugly, I do admit that, but there's really no way to dynamically create a statement like this without doing it that way, okay? Now in the end, you're not going to actually use the Euclidean distances. You're going to put in a couple more lines of code, and you're actually going to, you could still use this output name, because you only need to save the one you care about. You don't need to save any of the other ones. So you're going to have a couple lines of code in here, because first you need to get rid of those values that you don't want, and then you need to reverse the values, and you need to save out that data set. All right, but I'm going to show you the final statement here, is that you need to write eval statement. So in other words, what you're doing is you're telling Python that this string actually contains a Python statement that you want executed. So this is the way that you build a Python statement inside of Python. And it's actually kind of considered bad programming practice to actually do this, but because of the way ArcGIS has built this module, this is the way to get around it. You have to do it that way. There's an equivalent syntax in other programming languages like JavaScript. But now the result is going to be all those values. Okay, so now it executed. Oh, but I didn't actually save it out, right? I just executed it. So it did add all those together, but I didn't save it out. I still need to do that particular step. And so I could add that on here and say, you know, output RAS equals this. And then under here, I'd have to do something like I need to give it a path. I'll just call it total.tiff. I'll run that again. No, where did I mess up? That shouldn't be a problem, roads plus raster. I don't know why all of a sudden that's a problem. Put that in the Python interpreter. So why didn't it work inside there? Let's look and see if it worked. Refresh. Total.tiff. It looks as though it worked. It's just kind of an addition of all the, that's not the actual final that you need, but that's just a mesh of all of the different data sets. Now I got to figure out why this didn't work, because it looks like it should work, and that's the point that it's pointing to. Oh, you know what? I think that let's see if it likes this better. Because you can actually do this too. I'm gonna close down our catalog just to make sure. And run this guy. So this is just assigning it a value, because the eval function will actually return a result, but I don't know if this will work, because that result should normally be a Python data type, but it's not a Python data type. Oh, it worked. Looks like it worked just fine. So that's the way I would do that. Okay. So let's talk. Let's make sure it worked first. Yep. Okay, that still worked. Okay. So let's talk about what you need to put in here. Basically, you don't really need to save this right here. You don't need to do that save part. You're not going to do that save part. What you're going to do, rather than that save part, you're not going to save it until after you do step 4 and step 5. So let's go back here. Look at step 4 and 5. And 4 and 5, hopefully I'm right. But yeah, so 4 and 5. So you're going to so what you're going to do is adjust the output so only distances up to 1,000 are present. You're going to go beyond 1,000. There's actually a step there that you need to do Trying to think of a different way to do it. Yeah, okay. All right, this is what you actually need to do. I'm thinking of it as a different step, and I can make this look a little bit more clear. But ideally, what you want is that the values need to start with 1,000 when they're right up next to the feature, and they need to tail off to 0 and continue to be 0 even outside at that point. Everything greater than 1,000 needs to be a 0. So the best way to do it is actually keep it the way it is right now. And then what you do is you reverse the values first. So you take 1,000 minus 0. 1,000 minus the values in this thing. So what happens if you get a value of 1,005? What's 1,000 minus 1,005? Negative 5, exactly. So I'll change these two things. I'm going to do it right now so that it's that way. So what you want to do is reverse the values first, and then you want to do a conditional statement that says if the value is negative, assign it a value of 0. If the value is negative, assign the value of 0. Okay. So, and then you save that data set out as the temporary data set, add them all up, and do it. Okay? So I'm going to leave the code up here real quick. And I've got GitHub up in my office. I'm literally going to do it in 2 seconds. I'm not even going to stop recording.
Well, I wish I could drive because I could take him. And the little girl just looks just like I did. No. I really realize her. There's so many things in my body.
All right, I made it fairly concise, I think. So here's the updated instructions. So use the Euclidean distance to create a raster of straight line distances, and then subtract the values in the Euclidean output from 1,000. It's 1,000 minus the Euclidean distance output, and set all the negative values to 0 as the next step. I should maybe write a hint using the con statement, but that's already demonstrated in one of the examples. So you can do that. And then add up all these values, and that is demonstrated here. So you can do that. And remember, you don't need to save any of these other intermediate steps. Right now we have them saved, but you don't need to save those intermediate steps. You only need to save the last step, because that's the step that you're going to put into the raster. Now, if you get something that you don't expect to see, save out the intermediate step and see what it looks like. Okay, so I could actually, do something like this and say, EUC dist plus, so now it's going to, when I run this, it's going to create a, well, now it's going to fail down here because I'm saving it as a different name, but now I could use that as the, no, it's not gonna fail, but anyway, I guess what I'm trying to say is now I have a bunch of file names with EUC at the beginning of them. So if I also wanted to save the, after I did the subtraction, I could call it, sub underscore whatever. And then if I also wanted to save it later, I could save it. I'm gonna delete that for now, but that'll be just like a little help you. There's no reason you can't save all the intermediate steps. What I'm trying to say is you don't need to save anything except for the one that you put into this big statement down here. That's the only one you need to save. Are there any questions? All right. Now I'm going to